Hello everyone, welcome to RECode 3.0 conducted by the Coding Club PSC Tech. I am DHANUSKUMAR from 3rd year BCSC. Let's get into this video. In this video, we will be exploring Pandas, a powerful Python library. And here is what we will cover. A brief description of the tool, the key features and functionalities of Pandas library, a project description, and a step-by-step demonstration of how to use Pandas, and finally complexity analysis. Let's go through each section one by one. Let's see what Pandas is. Pandas is a free Python library used for handling and analyzing data. Pandas gives us powerful tools like data frames and series to work with structured data easily. You can use it to clean, change and group your data, and it also helps with reading and writing files like CSV, Excel and SQL and so on. A data frame is like a table or spreadsheet that makes data manipulation simple and intuitive. We'll be using data frames in our project to handle and analyze the data efficiently. Let's see some of the key features of Pandas library. First one is data structures. Pandas provides us two key data structures. First one is series, which is like a single column, and second one is data frame, which is like a table. In view of data manipulation, it is used for cleaning, filtering, grouping and merging data. You can easily read and write data in formats like CSV, Excel, JSON and SQL. It also comes with built-in aggregate functions for making data analysis quick and efficient. And more importantly, it integrates well with Matplotlib, which is also a Python library, for creating charts and graphs to visualize the data. Let's look into Matplotlib. Matplotlib is a powerful Python library that allows you to create all kinds of visualizations, whether it is simple static plots, dynamic animations, or even interactive graphs. The reason we are using this library alongside Pandas is to enhance our data analysis by making insights visually accessible. Some of the key features of the Matplotlib are variety of plots. It supports various charts like line plots, bar charts, scatter plots, histograms, and pie charts. In view of customization, you have extensive control over styles, colors, labels, and annotations, making your plot more informative. It integrates very well with Pandas, NumPy, and Jupyter notebooks. Moreover, you can save your plots in formats such as PNG, PDF, and SVG. Let's see the short introduction of Google Colab. We will be using Google Colab for the demonstration of Pandas and Matplot libraries. Google Colab is a cloud-based Jupyter network environment that allows you to write and execute Python code right on your web browser without any installations. The advantages are no setup is required, and you can get free access to powerful hardware like GPUs and TPUs, and also it integrates with Google Drive, which makes sharing your projects simple. To demonstrate the tools, we will be doing the project which aims to analyze the relationship between the movie ratings and box office collections across different genres using movies.csv file. We will utilize Pandas to calculate average ratings and total box office collections for each genre, then visualize the results with Matplotlib. Let's see the step-by-step demonstration of the both tools. First and foremost, we have to load the dataset from the movies.csv file into a Pandas data frame. By cleaning the data, we can ensure that data types are correct and not handles any missing values. Then, we will group the data by genre to calculate average ratings and total box office collections using Pandas grouping functions. Finally, we will visualize the results with Matplotlib in a clear and engaging way. Okay, let's start the demo video. First, we have to search Google Colab on browser. After getting the search results, we can access it using the first link. The interface will look like this, and by clicking the new notebook, we can create the new notebook. The programming interface will look like this. At the top left, you can see the file name. You can change it as untitled to example or as of your choice. And also, you can see the code and text tabs. There are two main cells in Colab. Code. The code cell is for coding, and the text cell, it is for displaying the text like note and code description. You can easily identify the code cell by seeing the run button on the left of the code cell. Just put some text in the text cell, just demo text. So it will look like this. To upload the dataset, you can see the file icon on the left of the screen. First one is for table of contents, second is for find and replace, third is for variables, fourth is for secrets, and the last one is for files. In files, you can manage the files like copying the path, downloading file, or renaming file. There are four icons. First one is for uploading the file from the storage, second one is for refresh, and third one is for uploading the file from the device, Google Drive. We're just clicking the movies file. Now we can see the movies.csv file on there. Okay, let's start coding. First, we should import Pandas as PD, and then import Matplotlib as PLT or as of your own name to make the access more easier. After importing the libraries, first we have to load the dataset. Just delete it. df means data frame is equal to pd dot read underscore csv. On the bracket we have to give the file path. We can find the file path by clicking the three dot on the file name, that copy path. You can also download the file, just paste it, and we are using the encoding scheme to ensure that the data is read and loaded without any misinterpretation. For that, we are using Latin 1. Just encoding is equal to Latin 1, and there is also another coding UTF-8. Let's print the columns of the data set. For that, data set print the columns of df dot columns. It will source the columns of the data set. Further, if we run the code, it will source like in an unordered manner, like the below index of the index and the columns names. Further, we have to use toList. Then after running it, it will source the column names as in list. We can see the content of the data set. For that, hashtag content of the data set, and then print bracket df dot head bracket. Here we have to fill the number of rows will be displayed. I'm just giving 10. If we run, it will source the rows like 0 to 9. The 10 rows it will source. Since we don't need that much number of rows, just giving 5, then it will source 0 to 4, the 5 rows. As we discussed earlier, we have to clean the dataset. For that, cleaning of dataset. For that, we have to use df dot drop na bracket subset is equal to the subsets where the missed or null values can occur. We are just giving here runtime and then the awards. These are the columns where the missed or null values can occur, or else if you are interested to check the all columns of the dataset, you can give the all columns. Just after awards, comma, in place is equal to true. This is to update the same original dataset instead of trying duplicate one. If we run it, the missed or null values can be deleted. Before doing the main operations, let's see some of the basic functions and operations. Basic operations. Let's consider top 5 movies. Top 5 movies based on the rating. So we will see top 5 movies based on the rating, and also we will see based on the box office collections and awards. So we are going to declare a variable top rated movies trm is equal to df dot n largest bracket 5. Here we use 5 for top 5, or else if you consider top 5 or 10 most, you can use 10. On the bracket we have to give the columns of the result like title, comma, rating. On the output it will be displayed as title, comma, rating. Just print the variable which contains the top 5 movies. Print top 5 movies by rating, comma, just give the variable name trm. If we run it, it will show the top 5 movies based on the rating. You can see the top 5 movies by rating 8.5, 8.2 and 8.1. And then let's see the top 5 movies based on the box office collection. Top 5 movies by box office collection. Let's assign the variable tbm top box office movies is equal to df dot n largest bracket 5. Let's assume the top 3 comma on the single quotes we have to give bo box office collection. After that we have to give the column names title, comma, box office collection. Just a second. Title, comma, box office collections. After that we have to print top 3 movies, print top 3 movies by box office collection, BO, box office collection. If we run it, it will show the output. Wait, there is an error appeared. The error is because of the type error. Type error is nothing but there is the column, that box office does not contain the integer values. Instead, it contains the string value. For that, we have to convert the box office column values to integer. Convert the box office collection. Just put it here. Convert the box office collection to numeric df. For that, we have to use df of box office collection is equal to df dot df of box office collection on the single quotes BO box office collection. We have to replace the B, that is billion, and the million M to the null value. Null value is nothing but the space str dot replace B with the empty space, empty string, comma empty string, and also we have to replace the M, million, str dot replace bracket M with the empty string. As type int, a float as type 2 because of 2.933. We just keep it as float. If we run it, it will show the correct format. Top 3 movies by collections 974.0, 970, 962. After performing the simple operations, next we are going to the main objective, that is computing average rating and average box office collection by genre. For that, first we have to give the variable name as AG, average rating by genre, is equal to df dot group by, on the bracket we have to give genre, in which we have to do the group by function. Genre on the bracket rating, and after that dot mean bracket dot reset underscore index. Reset index is used for the ranging the data between 0 to n. After that, we are going to calculate average box office collection. We have named the variable as abo is equal to df dot, we are using group by function of journal. On the we have to give the column name as bo collection. On the same function we use for the average rating, mean. On the average rating we have to change mean, and then mean dot reset index. After that we have to merge the both averages. For merging it once again, merging it, a underscore s is equal to pd dot merge both, that is ag average rating comma average box office rating comma on which we have to use, we have used the group by function, that is journal attribute. After that a underscore s dot, we are setting the column names as columns is equal to journal comma, first one is average rating comma, the second one is average box office collection. After merging the data, we are going to print the data. Print average rating and average box office collection comma, we have to give the variable name as, which contains the merged version of the average rating and average box office collection. If we run it, we can see the merged data. That is, if we run the code, we can see the merged data as average rating and average box office collection by journal. The reset index, that is from 0 to 8, action, adventure, animation, comedy, drama, fantasy, sci-fi, superhero, thriller. These are the genres, and those average ratings are and average box office collection are given. After that, we are going to use the Matplotlib to visualize the results. Matplotlib. First, we are using plot1. Give the module name plt or figure size. Just setting the figure size. As 20,10. After that, we are using the bar chart for average rating. For that, we have to give the code as plt dot subplot 1, 2, 1. plt dot subplot 1, 2, 1, which divides it as 1 row and 2 columns and 1 on the left side. After that, plt dot bar, we are giving bar for bar chart. If we are using the pie chart representation, we can give the pie. Just we are using bar, so bar just we are going to visualize the average rating. For that, ag comma journal comma average journal comma rating. Journal is column and rating of the rows, and we are just giving the color is equal to sky blue or some other colors on your own, sky blue. And then we have to give the title for the graph, plt dot title as average rating by journal. And then we have to name the x-axis and y-axis. X label as journal and the y label as plt dot y label as average rating. And then we are going to use the pie chart representation for average box office collection. For that, we are going to use plt dot subplot 1 comma 2 comma 2, which means 1 row and 2 columns and 2 on the left sides. 1 row and 2 columns on the second position of the grid. After that, we have to give plt dot pie. We are using pie chart, so for that pie abo on the bracket bo collection. We have to give the labels as labels which contains on the pie charts pie names is equal to abo journal comma auto pct is equal to 1.1 f The auto PCT is used for percentage format like 99.9%, and after that we have to give start angle at where the first page starts is equal to, just give 140 since there are 8 to 9 attributes are there. Then we have to give plt axis is equal. The plt dot axis of equal is used to the plots are equally distributed, and after that we have to use plt tight underscore layout and to show the representations plt dot show. The function plt dot tight layout is used to adjust the axes and labels to show the data clearly. That means the representation of the graph will be shown as clear. If we run the code, it will show like this, like the pie chart: sci-fi, superhero, thriller, action, adventure, animation, comedy, drama, fantasy, sci-fi. Let's see the complexity analysis of the code. Basically, it takes order of n plus order of n log k time for sorting and grouping operations, simply denoted as order of n plus n log k. Order of n is for loading and cleaning the dataset. On the other hand, order of n log k is for sorting and grouping data. Finally, I thank Coding Club PSC Tech for giving me this wonderful opportunity to explain the tools like Pandas and Matplotlib. Thank you everyone. Have a good day.